Now, so far we've been talking about an indirect approach to blocking the sunlight. So what you do is you put condensation nuclei into the lower atmosphere, and these in turn generate thicker clouds, and it's the clouds, the water, that scatters the light. But can't we just inject particles directly that do the scattering themselves, rather than this complicated procedure of thickening clouds? Well, this is the other main idea, which is to launch aerosols directly into the atmosphere and use them to reflect the light. Maybe sulfur dioxide chemical, which turns under sunlight into H2SO4, which forms tiny grains that block the sunlight, or dust or other fine particles. And once again, we have a natural experiment. We have been accidentally pumping huge numbers of fine particles into the atmosphere, causing pollution around large parts of the world, and we are continuing to do so. Here's a picture, I think it's Shanghai, showing pollution that was typical over China, and India and many other countries have very high levels of these pollution, these tiny particles in the atmosphere. And they are indeed scattering lots of light, and they are indeed having an effect on the climate. So here is an estimate of the effect of different chemicals on making the Earth hotter or colder. So you can see carbon dioxide is making the Earth hotter, as is methane. But look down here, aerosols. This is the air pollution. And it has two effects. One is a net negative effect, which is that all these particles scatter the sunlight away and make the Earth cooler. But also they blacken things by landing on surfaces, and also some of the black carbon particles directly absorb the sunlight and make things hotter. But overall the net effect is thought to be a cooling effect. You also get the changes in clouds due to aerosols, that these tiny particles, like we've been talking about for marine cloud brightening, act as condensation nuclei for clouds, and that's a pure cooling effect. So, pollution, good. These fine pollutions cools down the world. But it also kills 10 million people every year, and we have to be constantly putting out huge amounts of pollution. We're doing it by accident at the moment, but we don't want to keep killing all these people and making everyone unhealthy. But the reason you need to put so much in is because these particles don't stay in the atmosphere very long. Because they act as condensation nuclei, water droplets form around them, and eventually the water droplets become big enough and cause rain and wash them out down to the ground, where they produce acid rain and kill plants and fish and so on. So that's still not a good thing. But is there something we can do to put particles up there so they don't kill people, and they stay in the atmosphere longer, so we don't need to put so many billions of tons in the atmosphere, and so they have more or less a pure cooling effect? And luckily, there is a natural experiment for this too, which is volcanoes. Some of the big volcanoes, most famously Mount Pinatubo in the Philippines in 1991, kick huge amounts of dust, and particularly sulfur dioxide, very high in the atmosphere. The cloud from Mount Pinatubo spread around the world. Here it's viewed by NASA satellites. So this is the optical depth, so how much of the sun's radiation is blocked before the eruption. And here it is shortly after the eruption. You can see a band with lots of absorption, almost more than 10% of the light being absorbed, all around the equator. And as time went on, from July to August, it starts spreading out further and further. And even several years later, there's still a net effect, only it's now spread all over the world. You can see how this affects the amount of light getting through. At the Mauna Loa Observatory, the same one that measures the amount of CO2 in the atmosphere, they also measure how much sunlight is getting through the atmosphere. And what you can see is that normally it's 93% or something on a clear day, but it drops every now and then. And these drops correspond to volcanic eruptions. And here's a drop due to the Pinatubo eruption. There's also a smaller drop due to other eruptions, and a short, sharp one due to the volcano El Chichon. So it definitely is blocking solar radiation from reaching the Earth's surface, even halfway around the world in the other hemisphere, in Hawaii. What's its effect on the temperature? Here's a temperature anomaly, and you can see the period when there was lots of absorption. The temperature on the Earth does seem to drop. It's a bit of a noisy signal, but most estimates are that the Mount Pinatubo eruption caused about a half a degree or slightly more cooling for about a year. So it looks like whatever the volcanoes do to put dust in the atmosphere, the sulfur dioxide, it does seem to last longer, and it does really seem to cool the Earth down. And we've got the natural experiments of volcanoes to do this. So why do the volcanoes produce the pollutants that aren't killing people and stay up so much longer?